All right, well, welcome everyone for the joint NRRA meeting, joint team meeting. My name is Ben Worel. I'm the NRRA Executive Director and I work for the Minnesota Department of Transportation. Welcome everyone. And today we'll be going through and it's basically each team has some time to talk about general topics that they're working on that might relate to the other teams. And today I'll start it out by talking a little bit about kind of what's going on with NRRA, kind of the timeline that we have. Basically, we're moving into phase 3 and just going back, we had pooled fund 341. We're currently in 466, the second phase, and that'll be ending in February of 2026. But we do now have posted solicitation for phase 3 at 1631. If you look at pooledfund.org, you can just bring that up. There's not many new solicitations out there, but NRRA is one of them. And I'd like to say that now agencies can commit their funding for supporting the NRRA phase 3. And I'll talk about the different funding options and things like that in a second. But again, that'll be starting up in February or March, probably March 1st, and going till 2031 for phase 3. And so that's a good deal. I have to give Missouri, hats off to them. They've posted already their funding before MnDOT even has. So thanks to Missouri and thanks for all that. We'll be kind of looking at that. The idea is to get this kind of look that over and get your commitments in by January 1st so we kind of know what we have to work with moving into the next phase. And kind of talking about next phase is I do want to have some discussions about what things have went well, what things maybe could have done better, what opportunities there might be for phase 3. So in the next couple months, I'll be talking to the chairs about their ideas to the executive committee, but also be talking to all the members through the teams. And so if you have ideas or things that you think that we might need to do to tweak this, to improve it, ears are open to hear that and kind of work from there. Also kind of talking about construction. We have some plans for 2025 on the low volume road. The Flex team will be talking about the kind of additive sections that they're going to be doing. And also that's kind of reflective cracking aspect to that also. And the Geo team will be maybe talking about the flooded road. We are going to be constructing in our stockpile area. We have 950 feet of 2 roadways, a 7-ton and a 9-ton road that's been there for quite a while. We have a pond next to it, so we're going to be building a dike. The Geotech team has developed kind of a working group or a TAP to kind of guide us on how to flood it, look at what recovery and what monitoring we do. And then possibly in phase 3, then we can then have a contract to analyze the data and put that into the app that was developed through NRRA. So some activities that are going on at MnROAD. Again, construction ideas for 2026. We do have test sections available on the low volume road. So get your ideas in. Again, we can do a little more time for planning for construction in 2026. But again, that's due in December of 2025, I should have stated. So when I talk about phase 3, again, it's the same membership for full membership for governments, agencies, including the tollway, 75 a year or 150 a year, Minnesota. So that hasn't changed. That'll be the same. But there is a couple options that are going to be available. Minnesota is working for having an implementation focus. If you wanted to add 30,000 a year to that, we could do some different things for implementation. It could be looking at different reports, but again, something we need to talk more about. There is an option that some states have asked for is additional travel. In the pooled fund solicitation, it talks to it a little bit more. Minnesota's not going to do that, but for 10 grand a year, you get some more trips in there. And also there's an option like we've done before and we've done in the past for phase 1 and phase 2. Federal Highway did this, Missouri did this. put in just extra money for extra research. So they used NRRA to kind of do that. And that worked out really well for the Missouri additive sections that we are kind of looking at along with the NCAT issue efforts and MnROAD efforts. But again, Federal Highway's done that for looking at the low carbon concrete and things like that. So again, keep in mind that if there's something that each state wants to fund, they can do that through there. Again, the ICT only membership, New York and Georgia did this before. That'll be $30,000 a year. Minnesota's already covered. Again, if you're a full member, you're already part of the ICT team. But again, $30,000 a year, that's up $5,000 from 25. And again, associate memberships for universities, associations, consultants, that's $2,000 a year, and that'll stay the same. So those are the different options that will be available, and that's all on pooledfund.org under NRRA solicitation for phase 3. I also wanted to mention too that New York has funded kind of the partnership with NCAT for the NexPave challenge. So they'll be doing that for the 27 through 30 cycle of NCAT. But what NCAT does is works with us to have a no-cost partnership with them. So they help kind of fund some of the different joint activities we do. And this has really helped out for the cracking group study that we did before, the additive group / NRRA reflective cracking challenge. It really supports a lot of that, kind of doing that joint research. And so we'll be doing that. Again, here's some of the activities we're looking at possibly doing. NCAT's going to be reconstructing in 2027 and us in 2028, but the possibility of having different test sections to support some national efforts through that. And I just wanted to mention that just so you're aware of kind of when you hear about the NexPave effort, and how that ties to MnROAD and also kind of ties to NRRA and the benefits we see with the facility and our work. So that's what I had today. I'll be passing it off now to one of the teams, and I guess we really didn't establish which teams. So I will pick on the flexible team and Curt Dunn. If you could do your presentation, that would be great, and we'll utilize the rest of the time. Thank you.
Okay, thanks, Ben. And so I'm just going to share my screen here. Let's see. So welcome everyone. And so we have a pretty new project here called Recycled Binder Availability. And just kind of getting going now and everything, kind of getting past the work plan and everything. And so I'm Chris Williams, who is the principal investigator, is going to discuss some of the details of the project, briefly discuss them today. And so I'll just read here. Dr. Christopher Williams is a professor of civil engineering at Iowa State University and has more than 25 years experience managing and directing research funded by government agencies and other major corporations. So Chris, if you want to take it over, if you want to share your screen.
Yeah, I'll
stop sharing here and
try to. I'm not the best at these technologies at times, so hold on just a moment. There we go. Share. Michael, share my screen. And then I think we can go back to the for this and start the presentation.
okay. Sounds good.
All right. So thank you for everyone that participated in the. I never quite remember if it's a technical advisory panel, technical oversight committee, but the panel that we had a meeting with a couple of weeks ago outlining the work plan and So I think we're going to have the official start of the project in the next week or so. So I'm the principal investigator, and then Mohammed Al Kashif is my co-PI at Oklahoma State University. We have a pretty comprehensive team of folks here at Iowa State. The way research has evolved in this type of project, we'll be using professional staff rather than grad students on the project. So basically, let's, okay, now it's moving. Wasn't moving before. So the objectives of the project is understanding the utilization of asphalt binder and recycled asphalt materials as a viscoelastic material in asphalt mixes. And then how would we include that utilization of that viscoelastic material in the asphalt mix design? So if we back up and look at some of the work we did years ago on recycled asphalt shingles, we determined that recycled asphalt shingles was utilizing kind of an upward percentage of about 81% of the asphalt in the recycled asphalt shingle. And that's from tear-off shingles. It's a little bit different deal with manufacturer scrap. So analogous to that, we've had this long-standing discussion in our asphalt community of what part of the wrap is the black rock versus contributing that viscoelastic material in the asphalt to the mix. So we're looking at a lab validation and field validation approach on this project. We propose an approach to incorporate recycled asphalt binder availability in both what we'll call the more typical, we call it the super pave design method in many states, but also include this in the balanced mix design framework. This was the proposed schedule, and obviously we're already through May and June. And so the schedule simply shifts a couple of months based on the updated start date. So it goes through, we're going to be conducting a survey or synthesis of NRRA member agencies' practices. We want to look at identifying test sites for high recycled asphalt material mixes. And then that's going to inform us of what is our plan, our experimental plan. Conduct field sampling and data collection. Then as is rather standard in NRRA projects, there's a 1-year annual report update. Then we're going to be, of course, doing lab testing, field distress, and performance data analysis. Then hopefully year 2 update coincides with the final report and publication and whatnot. And along the way, there's presentations and things that members of the NRRA are welcome to have us provide updates as well. So, we can drive into the details of this, but basically we want to ensure we have captured the literature and what's kind of the state of the practice, and understanding what the NRRA member agencies who are funding this project do in practice, and seeing if there's some opportunities to integrate that, of course, into our program and provide them with candidate, potential updates to what they're doing. So then we're looking at identifying test sites, and what we're looking at is a control section that has less than 20% recycled asphalt material. And then we're looking at 2 high recycled asphalt material sections. preferably above 35%. And so the devil's always in the details. But we really prefer at least a test section that's 500 feet long, that we can collect that field data as appropriate. We want to consider kind of like 2 levels of binder availability, right? So what we're looking at is if we look at the asphalt binder content and the recycled asphalt materials, we want to make some sound estimates of what percentage of that binder is actually being used as a viscoelastic material. And so we're going to go with kind of the standard practice that we're using, more or less, and then say, okay, this is where we believe the binder utilization factor is, or availability factor is here, and index that binder content up a little bit for the a second experimental section. And part of the thing is this is an example of we do have pavement test sections that are already out there. And so this was based on asphalt shingles study, but we also have, like in Indiana, we did project with RAP versus RAS. We did some good work in Missouri. And then, looking at the effective percentage of RAP with RAS. And so we have some sections that are already out there, and we have all of those sections geolocated. And it's possible that we might be able to use some of the data from these test sections. Anyone who's worked with me knows that I kind of have this storage facilities where I on larger projects like this one, it's kind of like Indiana Jones movies where you store your materials, right? And so I have some of the materials in storage from these projects as well as other projects, and they could be useful in this study. So then, development of the experimental plan. We're going to look at selecting what we call the control mixes, test the control using, ideal CT, discompact tension, ideal RT, and the Hamburg. Trying to identify the binder availability factor for the RAP. Look at what is the dosage for the higher RAM mixes. Test the mixes using the ideal CT, DCT, ideal CT, and Hamburg. So kind of saying, okay, here's our standard mix design, produces this binder content. But if we look at this binder availability concept, then is there an adjustment to the binder going in there? Then we're looking at plant mixes. So again, plant mix, lab compacted testing, binder testing, RAP testing. The other thing that we have the ability to do is we have some advanced systems where we can take the asphalt binder and we can create the serifractions in 100 200 grams fractions per fraction in less than 20 in less than about 20 hours or a day. Okay, and usually what we do is we take those serifractions, right, and we have the saturates, aromatics, resins, and asphaltenes, and then we kind of look at some transition points in these fractions, and so we can control exactly the molecular weight and how we divide these fractions. And so sometimes we'll create 6 fractions, whereas we're creating those boundaries between the resins and the asphaltenes, or the saturates and the resins, to examine some of those molecules. Okay, so then that enables us to then also look at, and if we're talking about the RAP, look at the behavior of that RAP across these different fractions. Okay, and so we may have the same asphalt content. We may have an asphalt content in the wrap, but those fractions of that asphalt is probably dramatically different than what we're using in the virgin binder. So we can easily benchmark that in our systems. We're also able to run, we have a pretty advanced extraction recovery system, and we can extract and recover about a kilogram or more of asphalt binder within a day. Okay, so we have a pretty high production facility in doing extraction recoveries, then further fractioning those asphalt binders and looking at them in more detail. So here we just have some examples of what we might be looking at in the experimental plan. Okay, and again, these are just hypothetical situations. Okay, and so then we can look at when as we move towards 30% binder coming from the recycled asphalt materials. It's going to be increasingly difficult to achieve that binder grade simply using let's say a crude petroleum material that has lower molecular weight to meet that spec. And so then you're going to move into other kind of recycling agents. And AASHTO has a list of recycling agents that are qualified. And there could be other ones, but I'll leave that up to the NRRA panel to guide us on what they want us to examine. Okay, but this is an example of what you can find with some of these blends that we see. Okay, and then if we look at the binder availability factor and we apply that and how that virgin AC could increase, right? So then we'll progress to the field sampling data collection. I think, of course, we're going to need to look at the plant type, the method of how the recycled material was added, the silo storage time, production rate, haul distance times, etc. We can, on the one hand, be at a portable plant, 300 ton per hour production. Could be a little bit further haul distances, but we could also be at a facility that's pushing 1,000 mixed tons an hour. They light the burner at the plant at 2:30 in the morning or so. They got 12 silos. You're filling the silos up, and then the mix is sitting in the silo for 4 hours maybe for loadout or even longer. Right. So there's things that I think we should go through and document what's occurring in the material production. And so along with that, looking at mixed temperature, compaction temperature, laydown operations, collecting the QC, QA data, and things of that nature. Looking at the mixed constituents, if you're going to have a quartzite, primarily a quartzite based mix, you're gonna have different absorption values than let's say a limestone mix, right? So we need to keep track of those things as well. And of course, we'll be obtaining field cores.
Chris,
yeah.
Sorry to interrupt there. Could you wrap it up maybe in just a few about half a minute here? We got some other updates here too we got to get through. So
well, okay, sure. So
yeah.
Anyway, I think all this is posted online, and so then we'll make the recommendations, and then the oversight committee will review those and then we'll adjust as appropriate. So that I'll just say thank you and take any questions people might have.
I think we'll thank you, Chris, and if there's any states out there that would like to go in on this study, please let us know. So so with that, just to stay on schedule here, thank you very much, Chris. And so I have pardon me.
Yeah, no worries. Appreciate the
Okay.
opportunity.
You bet. And so I'm gonna turn it over to Michael here. He's had a couple-minute update before we can on some things happening at the test track. So go ahead, Michael.
Were you going to share your screen?
I'll bring my. Yes, I will. Yep,
All
I'll
right.
bring them up here.
Yeah, thanks again, Chris, for sharing for the Flex team. Just wanted to give a quick MnROAD update on everything asphalt related, a little bit PM related, and let everybody know, really just planting the seed. And if you want more information, please contact us. So we are removing the spray rejuvenator test sections on the low volume road. These sections have been in place for 4 years. We are at the end of the research contracts with those. We have year 3 testing that we recently funded through the PM team. That will be, those cores will be tested at NCAT. And then, so if there's anybody interested in year 4 cores or any kind of year 4 application or monitoring, I will be reaching out to the participants or reach out to me after this meeting. We are looking at the end of August, beginning of September to remove these sections. So it's now or never. The St. Michael test sections, which is shown in the bottom right corner here, those are going to stay in place. Those are the longer 500-foot sections. But the MnROAD sections, you can see in the picture on the bottom left, we've taken over 50 cores per section, some of them more, especially the controls. We're running out of real estate and we're kind of reaching the end of the experiment there. And then the final reports on those, both from the Michigan State team and from NCAT, we expect to have posted in the next several months. Next slide, please. And then we're going to be using this real estate. So Caterpillar, through the MnROAD Caterpillar partnership, is going to be doing milling to remove those sections. They are doing something similar to what we did through the University of New Hampshire during MnROAD's last construction effort, where they are looking at mill speed, rotor spacing, T-spacing, those kind of variables. So they're going to be playing with this area to mill up and remove those sections. And then in place of those, we're going to be constructing a low volume road version of the MnROAD NCAT additive group or MnROAD reflective cracking sections, where we have 3 different additive products. We're going to take our typical 400-foot test section. We're going to cut it in half. We're going to have saw cuts in the lower common lift, and then evaluate both the low temperature cracking in the uncut portion, and then the reflective cracking in the saw cut underlying lift portion. We're planning on giving a more thorough update in the July or August Flex team meeting. So just wanted to plant the seed here. And again, contact us if you're interested in learning more about these. Thanks, Curt.
Okay, very good. Thank you, Michael. Sounds like a really great thing going on here. So with that, I think I'll turn it back over to Ben.
Yeah, thank you, Curt. Nice job, everyone. Again, all these things, each of the ones, you can go on to the NRRA website, and if you want to be on the TAP, please show your interest in that, and that's the way to get kind of involved with what Chris talked about and other efforts that are going on. If I could go next to the Geotech group, Raul, are you there, and would you be willing to present?
Yes. Good morning,
And
everyone.
so as Raul gets us going, I think I'll do the PM next, then the rigid, then the ICT team. So Raul, take it away.
Good morning, everyone. Brief update on projects on the Geotech team. We currently have 5 projects, 5 active projects. 3 of them related to pavement foundations that I'm marking here with a cross, and 2 of them related to subsurface characterization and deep foundations. The weekend geotextile, we're almost done with it, about 80% completion. And for the pile project, pile on sands over prediction, we are working on the contracting aspect. So in the next few slides, I'm going to just provide some highlights of what the PIs would like me to share with the NRRA on current efforts. So I'm going to start first with the Weekend Geotextile project. So they wanted to highlight the results from the large-scale laboratory testing that they have completed. They indicated that moisture sensors in their experiments confirmed that the section reinforced with the Weekend Geotextile maintained lower moisture content during freeze-thaw cycles and rainfall simulations. Here are some pictures of how that large-scale testing looked like with those heat exchange elements. And here on the right shows the probability plot, cumulative probability distribution plot, indicating that the Weekend Geotextile section, which is the blue curve here, show up to 36% higher probability of experiencing lower permanent deformation in comparison to the control section, demonstrating the enhancement in performance for both hydraulic and mechanical stabilization. So that's important to highlight that Weekend Geotextile provides both improvement in water management and mechanical stabilization. For the flooded pavement as a app, work done by New Hampshire, they completed the development of a beta version of the app called PaveSafe, and they are currently testing and validating. Here we have some screenshots of the new features of the app. If you worked with it before, now you have several new features that are pretty interesting. For example, I like to highlight that they included now a feature where you can input your unsaturated soil mechanic characteristics, and specifically your soil water characteristic curve. You can input it by hand if you have some lab testing results available, or you can predict it or estimate it using grain size distribution or typical parameters that you have in the literature. So it very nicely shows you how that model fits your soil water characteristic curve and also your unsaturated soil permeability function. So that's pretty neat in this new app. Also, they improved the way to input the hydrological inputs like precipitation, how your rain looks like, so you can specify your rain events very nicely. And they also included loading, typical classification vehicles for loading, but also have the FWD option. So usually, for example, MnDOT uses FWD to go and determine if it's ready, if your road is ready for opening to traffic after a flooding event, and they usually use FWD to determine that. So we can use this tool. They included, because of that, they included the FWD loading for assessment of the condition of the road. So pretty nice feature. They have, for the past year, they have completed extensive rigorous testing in the lab, as shown here on the left, to validate some of the results coming out of the app and to determine the impact of different soil, of different moisture profiles in your soil and the response of your foundation. Very sophisticated test system with a lot of sensors inside. We look forward for the next update in our team meetings. I think they are scheduled for the next month or for the next month to provide a dive deep on the results from this app. For the water repellency project, they are working on evaluating organosilane treatment to reduce the upward movement of water. So they're pretty much focused on cutting the flow of water going upwards in your pavement system. Initial readings coming from the sensors indicate that the treated sections with water repellency and the treatment was applied about 3 to 4 feet deep into your cross section. Shows that they reduce somehow the moisture levels. Here in this photo of time history shows the solid lines is the control sensor, and then the dashed lines are the ones treated with this water repellency material. They have also done some nice work modeling to try to simulate other conditions that we cannot simulate at MnROAD. And they are right now currently working on validating those simulations. I'm sorry, that model using first simple small scale lab testing as shown here. Case 1, we have different layers of soil, and then case 2, they apply the treatment, a specific dilution rate, and they are capturing so far. They're trying to kind of back calculate the parameters of the sophisticated soil models for simulating freeze, thaw, and heave. Using Plaxis, and so far they have been pretty successful in fitting those those parameters. And then we're going to take this to upscale into a more comprehensive model to try to simulate different conditions, like, for example, freezing delay, frost depth reduction, how good this organoxylane treatment impacts water movement. So that's it. So kind of highlights that the PIs wanted me to show you guys in terms of what is Geotech doing recently. As Ben mentioned, there's been a lot of attention, a lot of engagement from members about the flooded pavement initiative. I call it initiative because right now there is not associated contract. We don't have a university or a contractor working on that project. So right now it's just an initiative at MnROAD. We have about 15 people that show interest in being part of that panel. In the next few weeks, expect an appointment for getting together to start brainstorming the best way to build that facility, that flooded pavement section at the low volume road, as Ben mentioned. So stay tuned for the next couple of weeks. We'll start getting together to discuss that further. That's it, Ben. Get it back to you.
Yeah, nice job. And just there's been a couple things in the chat and some of the speakers that have been talking about those subjects. You know, there's quite a bit of discussion to go with it, but again, note who's asking the question, and if anything, respond or get back to them with an email or something like that. That'd be appreciated. So thank you again. And thanks, Raul and the ICG team. Next up, the PM team with Tyler Hunt from, if you'd like to kind of take it from here. And I don't know, you don't have a lot, but let us know what you're working on. Thanks.
Thanks, Ben. Everyone see my window there?
Yep, we can see it.
There we go. Okay. Thanks. Yeah, I'm just going to go through, give our PM team update here. I'm going to have a few of our researchers jump in on my slides, I think, and just give kind of a brief update on the ones that are here anyways. So, Dr. Yu couldn't be here today, but the 2023 funded projects for the hot rubber seal coating, we have task 3 still underway. Lab testing comparison with conventional seal coats using MnDOT materials for that, and then we're also doing tests on asphalt content coated on aggregate chips. So MnDOT did complete field surface friction testing before and after on the segment. So that's all going to be looped in with the project. And then we're going to look at distress after multiple winters. So that's where we are with that project. I just snapped a few photos when we did a field review before and after, so I thought maybe the group could see. This is the western end of the project where we have the 25% hot rubber content. It's pre-coated chips, but no fog seal. So over on the left is before, the middle is the treatment. So you can see that the surface isn't beautiful without the fog seal, but it appears to be holding up well. It is shadowing some of the overband below, but the surface texture seems great, and I think things are going well for the condition of that pavement. So I'll leave the rest to Dr. Yu, and he's back, and he can update the group next time. We also have our second 2023 funded project, rumble strip durability. We have Faustina with us. If you want to take it over and just give an update for us, I'd appreciate it. If you want, do you want to share your screen or?
Yeah, sure, if you don't mind.
Yes, absolutely.
So I don't want to be repetitive here because you've probably heard this several times, and even Dan presented at the conference in April. But I just wanted to give a brief overview. The project is essentially wrapped up. Can you guys see my screen here?
Yes, yes, we can.
Great. So essentially what this project set out to do was understand, do rumble strips negatively affect pavement performance? There are a lot of assumptions and myths. So we wanted to understand what they do, and if something has been negatively impacted, do material treatments help mitigate these risks? So we had 3 field projects in Wisconsin. We cored them. We had sections, control sections, and sections with rumble strips. And the material treatments we evaluated were RPE, VRAM, and a combination of the two. So we did a top-down approach, a bottom-up approach, and then both. And in terms of lab testing, we, at a high level, we did more, but at a high level for performance, permeability, ideal CT, and Texas overlay. And we had a team on site doing functionality testing to measure inside and outside noise and vibration. Essentially, the report for task 5 is finished and it has been uploaded on the website. I can share my slides later. We have the link here, but I'm sure we're all familiar with the NRRA website. And the, I guess, interesting or appealing part of this is as an additional deliverable, we created a 1-pager to kind of condense the main findings of the project. And we tried to frame it around what people wanted to know about this project without having to read a 200-page report, but just, high level, easy to use, easy to understand 1-pager. And then the final report is under review by the editorial board. If I have enough time, I'd like to quickly go through that 1-pager to kind of share with the team. Again, I think Dan shared it as a preview during the conference in April, but I'm trying to share here. Here. Okay, I believe you can see it. So this is what we came up with as a 1-pager based on the known and recognized safety benefits of rumble strips. We wanted to understand moving forward what they do with in terms of pavement performance. So big questions that we wanted to ask: does milling of rumble strips degrade the mix? We didn't find any significant degradation based on our gradation results, meaning that the milling itself does not harm the integrity of the aggregate at the joint. In terms of permeability, our main finding was that we did not see a significant increase in permeability, although I should add that these were all fine-graded mixtures, so our permeability for our control was already pretty low, meaning that, yeah, our baseline was already low. They do generate a reservoir for the accumulation of moisture, and we were unable to do long-term aging on these cores because we started losing integrity. You can read more about it on the report, but one big portion of this would be to further understand long-term performance, which we hope to do in the future. In terms of cracking susceptibility, we found out that the main driving factor of the cracking behavior is not the rumble strip, but it's the presence of the joint. So our starting point has to be constructing a good quality joint. We did see through the Texas overlay that the rumble strips increased crack propagation rate. And to mitigate that, we found that adding VRAM at the bottom helped reduce that propagation rate after the addition of rumble strips. And the addition of RPE contributed slightly for permeability as well as crack propagation rate. This is mostly driven by VRAM, but the RPE kind of adds an extra benefit. In terms of safety and of outside and inside noise and vibration, our external study showed that there was no negative effect of these treatments. In fact, they do help maintain that inside noise and vibration while mitigating the outside nuisance for the surrounding areas, which is promising, which is desirable, I guess. So I guess in terms of a key takeaway for the project is that for performance of the joint, the key component is a good quality joint. That will drive everything else. And then for an additional risk mitigating strategy, I guess, the use of these material treatments is a helpful tool. Again, I went quickly through this. I'm sure several of you have heard about this before, but I wanted to share this update with the team. And this, as well as Task 5 report, are both available on the website currently. And that's all I have.
Thank you, Faustina. Appreciate it. I'm sure many have seen it. I just want to make sure folks who weren't at the conference and stuff had an opportunity. So I appreciate you doing that for me.
Yeah.
I'm going to tilt the screen back here. Dr. Dave, are you on? I have you up next.
Yes, Tyler, I'm on here. You can just call me Eshan. So I just don't have really a slide on it. That's not really the project that you list. I mean, that's not directly the title of it. What I wanted to talk about is it's appropriate as Thinlays, but it's also really looking at the results coming from the original I-94 westbound test sections, which did include some of those were placed as Thinlays. So it's a joint effort between this PM team and the flexible team that's using the NRRA phase 1 reflective cracking study cells also in parallel to the reflective cracking challenge that's ongoing right now. So, as I mentioned, several of these were placed as thin overlays or Thinlays as a treatment. As you know from previous quarterly meetings, those cells have been removed just recently. They were on an original, very old alignment of I-94 with rigid pavement underneath. However, through the efforts of Michael Vrtis as well as others at MnROAD, they were able to core these sections, and now we have received these cores during the last month, and we are processing them in order to conduct some testing that also allows us to look at how aging has changed the properties. And Jacob Calvert and others at MnROAD also conducted performance data collection on these cells. Original study ended in 2021, but they continued data collection on it. So we also have cracking data and write data on it, which has been provided to us. So more to come on this project, but just wanted to mention that we have the field cores that were received and were done prior to removal of sections. We are testing them and also processing the data. And all of that's happening in parallel to the reflective cracking challenge study as well.
Awesome. Thank you very much for that update. So I just have a couple quick slides, Ben. I'll turn it back over.
Yeah, we are running a little late, so
yeah, I'll breeze through these. So the spray and rejuvenator section, Michael already covered that. Heidi is still working on getting that addendum done to the partial depth repairs, and I'll skip this slide. So I'll turn it back over to you, Ben.
Yep. And thanks again, Tyler, for all that you do for NRRA. I'll go to the rigid team and Tom. All right, so Tom gets his slides up here. All right, thank you, Tom. See, I'm not hearing your voice, so you got to unmute.
Sorry about that.
No problem. Take it away, Tom. Be quick if you would.
When does this end at 11?
It does end at 11. I think we'll
11:30.
11:30. All right. So never mind. I'm pushing people too fast.
A little panic there.
Take your time, Tom.
Okay.
Thank you. Thanks, Lauren.
All right, I don't really have any rigid team updates. However, I'm going to spend the time talking about the performance of some older test sections because I got a call from Jacob Calvert, who is becoming popular this morning, saying, you better get out here. The cells are cracking up. What are we going to do? And so I went out there and took some photos, and I think we're going to be okay for a while. And I just wanted to kind of share, the performance of these particular sections that have been out there quite a while, and they're kind of interesting test sections.
Tom, I think you muted
Tom, you're
yourself,
mute. Yeah.
please.
Thanks, Eshan. Hit the wrong button, Tom.
I certainly didn't go for it, but anyway, is that better?
Great. Yep.
Okay, so these are ultra thin concrete overlay, fiber reinforced concrete overlays, and these were constructed in 2013 on the low volume road. And I believe this idea was introduced by the local concrete paving association, looking for some thinner alternatives to overlays that could be done on existing concrete roads. And part of that thing was, at this time, this new thing called geotextile interlayer was really becoming more popular. So we introduced that as well. So the idea was to put down a geotextile interlayer and then put a very thin concrete surface on top and see how it does. And there was some validation. There was at first an experiment at the University of Minnesota in an accelerated testing machine called the Mini-ALF that showed that it was able to survive quite a few load cycles. So we had a little bit of comfort that it wasn't just going to bust up right away. And then because it's on the low volume road, it gave us an opportunity to kind of compare how this thing performed, with traffic loads and with just environmental loads only. It's not cooperating as far as advancing the slides. All right. So the design details, again, this is 3 inches of fiber reinforced concrete overlay, so extremely thin, small panel sizes, which are necessary to handle the warp and curl, 6x6 panels. This was put on existing cell 40, which was an original test section, and that happened to be a thickened edge design where it was about 5.5 inches at the center line and 7.5 inches on the edge. It was kind of a very older design that MnDOT used to do long ago. It had skewed joints and they were not dulled. And by the time that we got to this 2013, it had quite a bit of significant faulting from the traffic side up to 5 millimeters. So that's almost 1/4 inch. So this was pretty faulted. So that was pretty good test for whether we can put a non-woven geotextile on something that faulted and whether it would cause some issues. As far as the fibers that were used, in this case, back in those days, we were looking at 20% residual strength ratio according to the C1609 test, which is kind of a residual strength test. And what we ended up with was a dosage of 6.5 pounds per cubic yard of this particular polypropylene structural fiber. As far as the fabric interlayers, we went with 2 weights. One was a standard weight, which we used for most thicker pavements, which is a 16 ounce per square yard. And then we went with something about half as much weight. So about half the amount of thickness as well, just to kind of see how these things performed. So what did cell 40 look like? It wasn't too badly cracked, but again, pretty significant faulting. So it wasn't really busted up. So we felt pretty comfortable trying this on this particular section, but it was really more of a test about those faulted joints. Again, you can see some mid-panel cracking going on longitudinal, both in both lanes, a little bit worse in the driving lane, which is to the right there. The inner side received most of the traffic. Actually, since this was an original cell at one point for several years, up to about 2008, it did receive one day a week, it received 102,000 pound load versus 4 days a week would be the 80,000 pound. So the outside lane had received some traffic, but since 2008, we adopted to leave that as environmental only and will no longer load that side. You can see some here preparation for some of the instrumentation that we put in there. And at this time, we also started working with North Dakota State University with some fiber optic sensing. So they brought their sensors out and installed them on top of the existing surface. You can also see there that small gray object is a thermocouple tree that we installed, and then also some dowels to hold some sensors that we were going to put in to measure what's going on as these joints underneath are opening and closing. So then we installed the geotextile interlayer, which again at this time was kind of a newer concept. MnDOT was slowly adopting it, starting to be used around the country. And one of the challenges is always trying to anchor that to the existing pavement. And up to this point, it always been shoot some nails into the concrete. Didn't always work. Sometimes it got shifted around by traffic. So this was the concept that came up with, why don't we try gluing it down? So at this point, 3M, who is in Minnesota, of course, came up with a magic potion, which I think they kind of said, well, it's kind of based on the stickiness on your Post-it note. So they brought out a thing and kind of sprayed it down on the pavement, and we put the fabric down, and it held actually very well. And it has the added bonus that if it gets a little wrinkle, you can pull it up and reset it. So worked pretty well. I don't know if that was the first application, but I believe it was. Paving went pretty well, except again, with 3 inches, the paver went very quick. So they had to keep up with finishing and getting it cured and everything. But nevertheless, it turned out pretty well, given, again, they weren't used to paving something as thin as 3 inches. So this is what it looks like afterwards. Again, the 6x6 panels, got some good longitudinal texture on there. You can see the fabric there, a little bit carrying over on top of the shoulder there. So after about a year, we had a few panels showed, a little bit of transverse reflective cracking. Wasn't overwhelming. You kind of see we snapped a chalk line there to kind of show, because it's kind of hard to see the very tight crack that formed over an existing joint. We really didn't see too much of that. And again, just to give you an idea of how much traffic this particular section gets, it's at least 70 passes per day of an 80,000-pound tractor. So it's pretty heavy loading for something this thin, but that's really, it's kind of part of the accelerated portion of MnROAD. And also, if you can demonstrate it can take this beating, you have quite a bit more comfort in a normal setting, maybe on a city street where you're certainly never going to see that much traffic for many, many, many years. So cell 40 is the one with the thinner fabric, and you can see took up to about 4 years till we started to see a little bit of significant cracking going on. Again, very tight cracks. I think the fibers are doing their job. We did have a transition between the two legs of the low volume road, and that's why you see a little bit more cracking where the traffic would come off that transition, and a lot of turning traffic in that location. So that did tend to crack a lot sooner and a little bit worse. But nevertheless, again, at this point, the cracks were still pretty tight. At the same time, this is the one with the standard fabric, so a little bit thicker. Again, faint longitudinal cracks starting to appear at year 4. We had one reflective cracking that happened even in the original section. It busted up because they had some poor compaction of a conduit going across the road, and that reflected right away. But again, that crack formed pretty quickly, even after about a year. And it's been there ever since. And again, just the fibers are keeping it together. Year 7, longitudinal cracking again. More and more cracking showing up, again, longitudinal in this case, especially again to the left photo, in the left, that's looking back. So now that's the loaded lane on that side. And then the opposite on the other one. Did get a little bit of cracking going on in the environmental non-loaded lane. We do get some traffic that goes on it, so maybe you can't say it never gets traffic, but it's much, much lower, and we don't intend to traffic it as little as we can. So as of last fall, this is what the survey looked for. The distress survey map looked for like cell 140, which is the thin fabric interlayer. You can see quite a bit of difference between the driving and the environmental lane. And you can kind of see the cracking pattern. Predominantly longitudinal, and then sometimes eventually they connect across. Again, all of these cracks are being held pretty well together by those fibers. Then you look at the standard fabric, quite a bit less cracking. It's not to say no cracking, but quite a bit less with the thicker fabric. This was just taken earlier this month, or I guess last month. And, you know, when I got the phone call, I went out and snapped some photos. So you can see there's a lot of cracking going on in these sections. But again, they're being held together with those fibers, and there's really nowhere for it to go because you got a good concrete base. So I guess we can probably get if we need to, we can get many, many more years out of this. Although I think at this point, we'd probably say this experiment is done and we'd like to replace it with something else. But at this point, you can see we've had about 106,000 laps of an 80K semi. So this is pretty robust stuff and still together. So again, you'd have a little bit of comfort using it in a lower volume setting. This is a thicker fabric. Again, a little bit less cracking. A little bit on, again, a little bit cracking on both lanes, but much less than the thinner fabric. One thing we did hear from the standard weight fabric was the report of clicking sounds, which is likely caused by the compression of the panels on top of that fabric. You have to consider that these panels are very light compared to the loads. About a 1,350 pound panel. You're putting the minimum weight is your front tire is 6,000 pounds. So these things are really getting compressed and moved around. Another thing we saw that was there's a lot lower stress on this thicker fabric. And that was found by the fiber optic strain measurements, where you can see the values are much, much less when you have the thicker fabric. So in other words, lower stress in the panels with thicker fabric, and you get less cracking. Joint faulting, you know, we didn't know what to expect. It turns out that whether it has traffic or not, really hasn't developed faulting, and you wouldn't expect to, again, with the fabric. Some of the higher readings you see there might be in the summertime. The panels are the joints are completely closed with the expanded pavement, and sometimes they'll maybe pop up a little bit and look like it's faulted, but nevertheless, not much change going on there. That's for the thin fabric as well as the standard fabric. So development faulting is really not an issue, and we didn't expect it to be. Looking at joint deflections, you can easily verify with the deflection under the load plate of an FWD that the deflections are quite a bit higher with the thicker fabric. But as far as load transfer efficiency, we don't see any difference. And in fact, you can see because of the range here, the fibers really are not really enhancing the joint performance. They're just kind of along for the ride. So kind of general observations, you know, the type and dosage of fibers used in these cells have functioned well in holding the panel cracks tight together, but they really haven't proven to really help in joint load transfer. And that we found that with other sections as well. And the thinner fabric resulted in panel cracking earlier than the standard fabric. Also, the standard fabric caused more audible joint clicking, and I know there was some work done by Bernard Hoegh, you know, kind of looking at a little bit more sophisticated analysis that you can kind of look into the sound produced by the two different fabrics. There was little difference in joint faulting performance between the fabric weights and also the level of traffic. In other words, faulting really wasn't an issue. And then the joint deflections, again, are much higher on the standard weight fabric, is kind of what you would expect. So I'd say in conclusion, the fabric interlayers in this application served well in reducing the reflective cracking from, again, the severely transverse cracks. So, and we've been finding that in other places as well, that the fabric does a good job of reducing the reflective cracking. And I would say based on the survivability of these, given the heavy loads at MnROAD, this is maybe something somebody might want to look at in a much lower volume road application. In other words, a city street. You probably have the issue though if you had curbs, again, you're losing some of the depth of your curbs and stuff. But however, it does prove that it is feasible to use something like this design in a much lower setting. With that, I'll take any questions anyone has on this particular topic.
I guess, Tom, when you talked about clicking of the road, that is actually when you're driving across it. That's the clicking you're talking about, the wheels hitting the road, and has different sounds to it. Just to clarify that a little bit.
No, it is actually, it was a little bit more than that, actually.
Is there? And what do you mean by clicking then?
Okay, well, I guess more like a thumping. In other words, you could hear the compression of the air, the compression of the fabric. So
okay.
Yes, you would hear, normally you'd hear the joint clicks just with the tires going across, but there was something more to it.
Oh.
And that's something maybe you'd have to consider in the residential area. You wouldn't want your pavement kind of pumping and becoming irritating to people. So,
I mean, could you hear that on the side of the road? Okay, go ahead.
I've experienced extensive joint banging, audible banging. You'll hear it early in the morning when the joints are more open or during cooler weather. And I've actually witnessed it disappear in the heat of the afternoon at the same site. So you might actually hear that and feel it in your feet. You can actually feel the vibration from that in your feet. And then you can actually watch that disappear as the slabs kind of curl themselves more flatter and they stretch out a little bit in the afternoon.
Hey, Ben, quick question to Tom. This is a good venue to ask this. Tom, what do you think is more why these interlayer geotextiles are more successful in concrete than in asphalt? My understanding is that for asphalt, it is not as successful. I have heard complaints from bituminous people trying to use geosynthetics to minimize or to deter reflective cracking. Do you have any thoughts about why it works very well with PCC and not with flexible pavements? Sorry to throw you. That's a tough question there. But this is I think, a good. And we have geosynthetics people here. We have bituminous people here. I'm curious.
That's a big subject there, Raul.
Yeah, they're just fundamentally different. And there are cases where I'm not a fan of geotextile fabric, because if your pavements are curled up, and then the pavement loads them and you have that stiff layer underneath. So there are cases where it could almost be worse to have something that thin, whereas the asphalt will have a little bit of give. And there's been a lot of concern about this keying in of joints, if they're extremely faulted, which I don't ascribe to that theory, but nevertheless, there's some fear of that. And the other thing going on is that this fabric, when you put it on the old concrete, is not adhered at all. So if your panels are prone to curling, they're going to really curl, because if you place it on an asphalt, they'll actually adhere to it and kind of help your built-in curls settle down a little bit. So the fabric has some built-in issues, but nevertheless, it's very, very good at reducing any kind of reflective cracking from underneath.
Thank you.
Hey, Raul, I would say that, in my opinion, it's because the fabric, the geotextile, provides a separation. So that does not bind the layers together. So probably if you have a thicker layers of asphalt on top of geotextile, maybe it can work, but not thin like that. So I think that's what I would guess.
Thank you, Dulce.
And I guess too, this is a kind of a bond breaker here. It's unbonded concrete. So concrete not bonded to the other concrete. The asphalt, you're kind of looking for that bond if you're doing asphalt over asphalt and things like that. And that's a whole thing on how intact it is and can you recycle it later on. Those are some of the complaints about it. MnROAD is talking to a group, one of the NRRA associate members, about possibly using a fabric in the sections that Michael was talking about, along with maybe we have a couple of sections of concrete that we need to bridge over until we have some ideas for it, just to keep the truck going. But there might be an opportunity there to do half the section concrete with a reflective cracking layer, then with an asphalt overlay over it. So we're kind of in discussions about that right now.
Cool. Thank you.
Yeah, it's a good question. Deepak?
Yeah, I have a quick question. Regarding this fabric, have you thought about the drainage as well that this fabric can provide?
Yeah. We believe it drains. I have some question about it also retaining a lot of moisture. What we found in the laboratory study is it kind of acts like a sponge. So when traffic goes over it squeezes the water out. Otherwise, it kind of retains water. So we haven't, until we kind of pull up and take a bunch of cores, I don't know that the constant presence of that moist fabric, if that's going to cause issues with the bottom of the slab. But that'd be one of my concerns. But nevertheless, it is designed to drain. However, again, unless you have a really good cross slope, it's not going to naturally just flow out. And that's really what we saw in the laboratory.
Yeah. All right, I think we're going to run to the next one. Nice question, Deepak. And if you want to follow up with Tom, I'm sure he'll talk forever on that. So that's why he's good at what he does. But again, thanks, Tom and the Rigid team. Kyle, with the ICT, would you like to kind of take us home?
I would love to. Let me share. Thanks, Ben. Let me share my screen here to give you guys some slides. Get that maximized. Okay. Yeah, so I appreciate the opportunity to give an ICT update here. Wanted to give a brief kind of overview and plug for the website where you can see all of the final reports from previous projects that if you go down this list, you'll see a lot of them are still hot topics and applicable today. So the other thing I wanted to briefly mention before getting into the meat of the update today is we do have a couple ongoing projects, one with traffic speed deflectometer and another looking at NDT methods for project level evaluation that Sahil Nazarian is leading up, and he actually gave a update. I think both of those projects had just got the survey results back. We were trying to make sure we had the most agency applicable NDT methods and some other questions for the TSD that we presented here. And Sahil and his team is going to present at the next kind of all NRRA group meeting to you guys on that. So. And then also wanted to mention we're co-sponsoring with Tom's Rigid team automated 3D GPR analysis for concrete pavement evaluation. But the meat for today is an update on VEDA, which is a software and an effort that NRRA has been great to support, and including this last round of funding, allowing us to kind of move forward on the MDMS, which is basically a way for us to do a better job of tracking and a safer job of tracking the mix as it shows up on the site, as well as a lot of other stuff. So, so this slide shows the 5 projects. I think we're up to maybe 6 now. If Rebecca's AMT unit is on, they might be able to give a more exact number, but we're piloting these projects here in MnDOT first, and my understanding is they're going well. There's this VEDA center where all the the data is sent. So that's the other kind of part of our intelligent construction technology effort, is to try to move our software that handles all these the data from these different technologies that's currently a desktop application to a cloud application, to get a little more ease of transfer and timely information out on construction projects. So right now with these kind of pilot projects, it's being sent to a Veda center on the cloud, and that's kind of the means that the data is being transferred from the site to all the people who need to have eyes on the data. And this is an asphalt effort for these pilots, but there's also an effort to try to get the MDMS for concrete too. And there's some contractor supplier limitations that they're working through. But there's been multiple meetings, and it does look like, last information I got, that there might be a project or two piloted for structural concrete here in Minnesota too. And one thing to mention here with the MDMS is, if these projects continue to go well, the goal for this fall, or as soon as possible, is to get this Veda MDMS capabilities out to the other states, so they can start using and benefiting from what's going on there. And it's also exciting from a DPS perspective, so a dielectric profiling system for compaction analysis, because it allows us to track where all the mix is coming from, which helps us with our calibration. So another kind of activity to update for this group is that we have a date for the initial pilot for roller mounted DPS in Minnesota. And actually, as we started to get this into place and reported on it internally, both for John Garrity, our bituminous engineer, and then also Rebecca, with the AMT unit, they have these periodic updates. Another contractor is now interested, so we might have another pilot actually sooner, July 18th this month. And what's kind of exciting about this is the traditional way that we're collecting density profiling system information is to try to map it out after the fact with either a truck mounted system or a push cart or things of that nature. But having it mounted on the actual roller, it frees us up both logistically and personnel wise, but then also gives us more real-time information. And then of course we already have the intelligent compaction is already kind of set up for being able to transfer the information, and we already kind of have a template in place. We're just basically, the way I see it, adding another sensor to the intelligent compactor. And so it'll be exciting to see how that goes later this month. And we have got our hands on some roller compactor data, and in comparison to kind of the more known technology, which is the push cart. And I guess the long story short for these next couple slides is we're seeing very similar lot to lot comparisons between what we get from the cart, which is kind of our known technology, and what we're getting from the rollers. So we're going to continue to do these type of comparisons and see if, okay, this low spot that we're seeing with the cart is also showing up as a low spot for the roller mounted DPS. And I mentioned before that the MDMS is exciting for the DPS integration, in the sense that it helps us a lot with our calibration. So it turns out with the DPS, what we're measuring, the dielectric value, corresponds really well to bulk specific gravity changes, or depending on how you want to present it, percent GMM relationship. But the key here being that it has to be the same mix or a very similar mix. And thankfully, mixes don't change too much within the same project. So as long as you're kind of locked in for the specific mix that you're using from the specific sources for aggregates, you're in pretty good shape. But there are times where, especially if somehow there's like a limestone to granite swap or something like that, where you can see a shift in our predicted percent GMM just based on the aggregate blend change, which we need to catch because we want to be using DPS to catch changes in air void content, not accidentally miscount a change in aggregate as an issue with actual density out in the field. So the idea here is, instead of having to kind of back calculate based on tonnage where these blend changes are occurring, we should be able to know with MDMS and VEDA these same comparisons that we're doing with IC roller pass counts or paver stops or thermal changes and their effect on our density out there with the DPS. We can do the same thing with aggregate changes if they occur in the field, and we can measure the dielectric of the volumetric pucks that way to track it. So yeah, so towards the end of the update here, I did want to mention with the DPS transportation pooled fund that actually just got authorized today. A big part of that is going to be supporting GHOST implementations for the participating states. And I'm really hopeful that this roller mounted DPS will work, because that's going to allow us to not just pilot it here in MnDOT, but also support GHOST implementations for those participating states, and see if they can also get some density mapped out with DPS too. And kind of the big picture is, like I said before, when we have this technology on the roller, the contractors seem to be pretty excited about it, in the sense that now, as part of their IC operation, they can actually see the compaction curve, and maybe it'll help them be a little more efficient with knowing when they've had enough roller compactor passes with that specific roller on that specific project. Or maybe it's deficient in certain areas, and they'll be able to catch that before it shows up on a core, or eventually when it shows up for incentive disincentive with our quality assurance using DPS as an agency. So with that, I'll open it up to the group if we have time for questions or anything that you want to discuss. And thanks for the time, Ben.
Yep. Any questions for Kyle? Lots of wonderful work he's working on with his team. Curt?
No, I don't have any questions. I just wondered if anybody had any for Chris. I know I kind of had to hurry a little bit there. Is there anyone that would like any for Chris?
Yeah, let's just I guess open it up for any questions on the presentations. While people are thinking about that, and I'll come back to that in a second, I just wanted to again thank all the chairs for all your hard work with NRRA. Thanks there's some MnDOT people that have been supporting those chairs, and appreciate their efforts along with the team members. It's really worked well for that. Again, the implementation side of it, NRRA is kind of offering a similar thing to what Kyle was talking about with the DPS. But so there's been a couple questions on the optimum asphalt content. I know, Jacob, you've had a couple of them. Do you want to, in a couple of minutes we have left, ask those questions and see if Chris can kind of work those out? I know Randy West had a question too.
Yeah, thanks, Ben. I was just curious, Chris, if that's something Georgia uses, the corrected optimum asphalt content, the COAC method. I think some other states use it as well, but I didn't know if that was included as part of that study or not. I was just curious.
Yeah, we're going to include that. Sure. Yeah.
Awesome. Thank you.
Randy, did you want to ask your question if you're still online or expand on it? I'm not sure if Randy's with us still. But again,
I don't think Randy is online, but I had the same question that Randy had. And it's not just limited to this project. The question's not just for Chris, but in general, because we had the same conversation, I think, in April at the NRRA meeting too, as states and agencies are moving more and more towards BMD, does the binder availability factor really matter? Or where does it matter in context of balanced mix design as a framework? And I think that's the question. So obviously, not just Chris, but anyone else, if you have insight on that'd be interesting to talk about. The second question, which Randy had, and so it's obviously you can see it on chat, was tied to the duration of the study, because it seems that there'll only be really 1 year to evaluate these field sections. And the question was, would that be sufficient to really see performance differences?
Okay.
So I guess I'll offer up that, when you go through the mix design and process, whatnot, there's, it's more of a, well-defined mix, right? But then when you get into field production, QC, QA, and tolerances, and then, I think many projects out there, we need to adjust the field production to achieve, let's say a PWL spec and stuff, whether it's density or binder content or whatever it might be, right? And so I think it gets into the devil's in the details there, so. So if we're, looking at, I would say analogous to a closed form solution in the lab, it's not always a closed form solution out in the field in production. And so it's how you want to capture some of these things. So we see mixes where field adjustments are increasing, from 20% wrap to 25. And then there's a cut in the binder content, but you want to drive that cut in the binder content to be, towards your target density. And then, hopefully, my recommendation is you want to have constant compaction and not always be changing your roller pattern in the field. So you're trying to, with the stockpiles you got, you're going to be hopefully producing towards a consistent, constant gradation as you can, and then those stockpiles can vary, and you're going to have to vary that. So at any rate, I think you get into the devil, the details can become rather complex depending upon the type of specification and expectations. Yeah.
Well, thanks, Chris. I know it's a discussion to be talked about some more. I know that's pretty complex and new for a lot of us. So thanks, Chris. And again, thanks for all the speakers. Looking for your ideas to make NRRA better. Doing this format for our teams meeting was one of the things that we talked about as a way to kind of communicate team to team, not just to your specific team that you're a part of. So again, that's one of the things that we've kind of done. If there's other things that you're thinking of, again, please send Lauren and I a note or talk to anyone with our staff or the chairs. Would be very much appreciated. So again, thanks again, and I hope everyone has a safe and fun holiday week, and see you in a little bit. Thanks.